Hello everyone, welcome back to another lesson in our first unit on Algebra 2. I'd love to end each unit, if possible, with problem solving. I want us to apply what we have learned so far to solving real kind of problem situations. And that's what math is really all about. It's not just about, abstracting out numbers and letters and solving equations. It's about solving problems and making people's lives better. So let's just dive right in and try and solve some problems together. So here we go. First example, we're going to solve the following problems using any strategy. Want to note this. This is says we're going to use a calculator when needed. In other words, we're going to use a calculator anytime we want. All right, we'll try and look at techniques to do it with and without a calculator, but I want you using a calculator because we're in the real world of problem solving, not practicing just algebra or arithmetic skills. So I want you to use every tool available to you. All right, Jed is buying bird toys. He buys 5 toys for $9.95 each. He has a coupon giving him 20% off the regular price, but must pay 8.25% sales tax. How much change will he get back from a $50 bill? Okay, so this is not an equation that we need to solve. We could try and set it up as an equation, but this is really just, there's nothing unknown to solve for. It's just calculation. So we're going to take our $50 bill, right? And we're going to subtract from that the amount of money that we spend. So let's just do a part. 5 times $9.95. But I have a coupon that's 20% off the regular price. So I get to multiply that by 20% off. So let's talk about what that is. 20% of something means you pay 80% of it, right? If I had a $100 item and I get 20% off, I'm going to pay $80. So that's what I'm going to multiply by. I'm going to multiply by 0.8, not 0.2, 0.8. All right, now I have to pay 8.25% sales tax. So I'm going to multiply this by not 0.0825, but 1.0825. Because I still have to pay 100% of the price. I just have to pay an additional 0.0825. Now, let's just simply use a calculator to evaluate that. So I'm going to go to Desmos here. And they have a scientific calculator. Let me just drag this over. They have a scientific calculator that you can use, but the graphing calculator works just as well. So let's just kind of position it in a way that we can see both here. And I'm going to do 50 minus 5 times 9.95 times 0.8 times 1.0825. And so it looks like I'm going to get $6.92 back, or 91 depending on how they round that. So let's just round it. 6 point, what did I say, 92? 6.92. All right. All right, so you may be wondering, is there other ways to do this? I think this is the fastest way to do it. We could get everything individually. We could say 5 times 9.95. We could multiply that by 0.2 and subtract that from the price. But that's so slow, y'all. That's so slow. Instead, just multiply by 0.8. Same thing with the sales tax. You may have been taught, you may have been taught that if you have a price P and you want a sales tax, you take P plus P times the sales tax, which in this case is 0.0825. Okay, that is so slow. The only reason why you would do that is if you're interested in exactly what the tax is. Instead, let's factor out a P, and when I factor it out, I get 1 plus 0.0825. And that's why I multiplied by that. Or just simply think about these percentage problems. When you pay 8.25% sales tax, that doesn't mean you just pay 8.25% of the price. That would be awesome, but no. You have to pay 108.25%. That's why I multiplied by 1.0825. Okay, so I'm calling that problem done. Let's go on to the next one. Okay, I told you this was going to be all about real world problems, and this is not. But still, you have to think. So we're thinking today. We're thinking. All right. Also, I know you need to review your properties. Okay, 12 plus 4 divided by 4 is the same as 3 plus 1. And 10 minus 3 times 2 is the same as 20 minus 6 are examples of what algebraic property. So what we want to do is we want to look and see what did they do and check that it's the same thing each one. It looks like they took the 12 and the 4 and divided it by 4 and got 3 and 1. That's distributive. Let's check the other one. We took 10 minus 3 and we multiplied each one of them and get 20 minus 6. So that is the distributive property. Okie dokie. Okay, smart, smarter, and smartest are a set of triplets in Mr. Young's math class. The triplets' combined average is 94%. If the average of smart and smarter's grades is a 92%, what is smartest grades average? Okay, so let's talk about how we figure out an average. We could sit here and just guess and test, and I guess that's a reasonable thing, right? But we have a combined average of 94%. We need to think about what that means. So I'm going to call smart X, smarter Y, and smart as Z. So what that's saying is if I take their grades and I add them together and I divide that by 3, I get a 94. And I know it should be like 0.94, but as long as we're just dealing with averaging numbers, this will be fine. I always say that an average, or more accurately, an arithmetic mean, is not an average, it's a sum. Okay? It's a sum written in another way. When it tells me that 3 people have an average of 94, what it's really telling me is that the sum of those 3 people is 3 times 94. That's what it really means. And you can see I can show that algebraically by multiplying both sides by 3. It doesn't tell me that any one of these people had a 94. It just tells me that combined, that's what they sum to. Now, 3 times 94 is... let's see here. 3 times 90 would be what? 270, so 282. You can check that on a calculator, but I think that's right. All right, now what does it say over here? The average of smart and smartest grades is a 92. Again, what did I say an average is? An arithmetic mean is really a sum. So if I have 2 people that sum to 92, it's telling me that smart plus smarter is 2 times 92. That's their sum. So X and Y has to add up to 184. Again, I don't know what X is, I don't know what Y is, but I know that they have that score. So that's going to go right here, 184. So what I can see is that I have, in this problem, 184 plus my unknown score for the third person has to equal 282. And I think you can figure out what that means. That's going to be a 98, right? It'd be 284 if it was 100, so it must be a 98. So we know the smartest was named well because she's got a 98% average. I assume it's a she. It doesn't say, but I don't know. If I'm going to name a kid Smartest, I think Smartest is a good girl name. What do you think? Maybe a boy. I don't know. Okay, Mark, Ryan, and Amber work at a car wash. Mark can wax a car in 60 minutes. Ryan can wax a car in 30 minutes. Amber can wax a car in 45 minutes. How many minutes are required to wax a car if Mark, Ryan, and Amber all work together? Okay, I love these problems. They sound kind of complicated, but they all work the same way, and they're really kind of neat. So what we want to think about is that this problem is actually, believe it or not, distance equals rate times time. That's all it is. We know that distance doesn't have to be a distance like from here to Seattle. Distance can be the painting a fence. completing a fence. Distance can be, in this case, waxing a car. So let's talk about Mark. Mark can wax one car in 60 minutes. So one car in 60 minutes. Let me rewrite this formula. We've already looked at rewriting formulas, right? If I divide both sides here by the time, here, I can use that, then I get that distance divided by time is their rate, right? Okay. So what that's telling me is if I take Mark can do one car in 60 minutes. So Mark's rate is 1 divided by 60. Now let's think about that non-algebraically. Just think about it for a second. As long as he's waxing the car at a constant rate, which we have to assume for this problem, what we're saying is that every single minute he gets a 60th of it done. So that after 60 minutes, he'll have one done. All right, well, we're going to multiply. That's his rate. Now remember, distance equals rate times time. We don't know the time that he works. So I'm going to call it t. So times t. All right, let's add the amount of work that Ryan gets done. Ryan can wax a car in 30 minutes. So that's 1/30th of a car every minute t. Amber can wax a car in 45 minutes. So that's 1/45th of a car every minute t. We're solving for when that equals 1. This is just a matter of solving this algebra equation. We can multiply both sides by the least common multiple. So I will. What's the smallest number divisible by 60, 30, and 45? I want to say it's 120 probably. What do you think? And there's actually some pretty cool tricks to solve this problem in different kind of number syncing sort of ways that you can do in your head. I'll let you look into that and think about it. But this is the way I'm going to do it. So I'm dividing 120 by 60, I got 2, and 2 times t is 2t. 120 divided by 30 is 4. 4 times t is 4t. 120 divided by 45. Oh gosh, that doesn't go into it. Oh, brother. Okay, let's try that again. 180. Okay, how about that? 180. Yeah, I like that. Let's try this again. 180 divided by 60 is 3. 3 times t is 3t. 180 divided by 30 is 6. That gives me 6t. 180 divided by 45. That's going to work. That's 4, right? 45 plus 45 is 90. And you double that, and you get it. All right, so that's 4t. That is equal to 180. So 9 plus 4 is 13. So the time is 180 over 13 minutes. What exactly is that? I don't know. Let's ask. Desmos, what is 180 over 13? 13.846 minutes. Wow, that was pretty fast. All right, let's take a look at how that we could solve this using a graph. How about that? Since these numbers are kind of messy, we just type in the equation, okay? And I'll use t, but I have to make this f of t. I could just use x too, but Desmos allows you to use functions, and I know we haven't talked about functions yet. That's next unit, but I think you've seen them before in Algebra 1. If you don't like it, just use x. Okay, so I got that graph. I want to know when does it equal 1. And so now let me pull this over here. There's our equation, and I want to know when does it equal 1. Oh, well, hold on. When does it have y equal to 1? So I got to zoom out here, and I got to find this little place right here, 13.846. So you see what I did? I graphed the equation, or the function, if you will, and I plotted y equals 1, and I'm trying to find when they equal. So pretty cool way to use the calculator to do it, right? Okay. Well, I looks like I am just chock full of work to do here. So I'm going to try and go over all different types of problems that I'm going to ask you to do, and then I'm going to give some for you to do. Okie dokie. Solomon, rows his boat up a river against the current for 14 minutes. He then rows back downstream to where he started in 7 minutes. If the current is moving 5 miles per hour, how fast can Solomon row in still water? All right, classic problem, classic problem. We got a river, right? And this river is flowing one direction here, okay? So that's called downstream. If you're going this way, this is called downstream. And basically what this means is that if you do row your boat, you're actually going to go faster than if you just, picked up your oars and relaxed and floated downriver. If you row upstream, you're going to have to overcome the current. I mean, it's even possible that you could be rowing as fast as you can and still going downstream if the current's moving faster than you can row. All right, so the current is moving 5 miles per hour. So we know that distance is equal to rate times time. So Solomon gets in his boat and he rows all the way up to some distance, turns around, and comes all the way back. So the amount that he goes upstream is the same that he goes downstream. All right? So upstream, how far did he go? Well, that distance is determined by rate times time. His rate is his rowing rate that I don't know, minus the rate of the water, which is 5, times the time. How long did he go? Well, 14 what? 14 what now? Minutes. My rate is in what? Hours. So 14 over 60. 14 minutes is 14 over 60 hours. And yeah, we could reduce that, but I want to make that clear that it's a fraction of an hour. Okay, so that's how far he went. Now, then he came back downstream at the same rowing rate, but this time the current is helping him, so he's being sped up. His rate is increased by 5. And that's why it only takes him 7 minutes. Now, you're going to like this, though. I'm going to multiply both sides by 60. Nice, huh? Yep, so it turns out we didn't even need that. So 14r minus 14 times 5 is 70, and then this becomes what? 7r plus 35. So 7r, when I subtract 7 from each side, is equal to 105. Divide both sides by 7, and you get, I think, 15? So 15 miles per hour. That is a healthy speed for rowing a boat. Maybe he's got an engine, or I don't know. Maybe Solomon's just like this amazing beast of a rower. Oh well, I'm notorious for not checking that my answers make sense before I write these word problems. I'm more interested in trying to think of funny names or put myself or my family or my pet, that's my dog, in than I am actually trying to make it make sense. Okay. Okay, Sue needs a solution of 10% hydrochloric acid in water. She currently has 20 ounces of a 15% solution of hydrochloric acid. How much water should she add to a 15% solution to reach 10% solution? Oh, come on. I'm being way too nice here. I can't believe I even gave you that hint. I should just ask you, what should she do, right? So, look, we've got hydrochloric acid mixed in water. We need to get it the right percentage to do what we want. We want it to be 10%. Currently, it's 15%. The way you solve that is you dilute it. You add more water, right? So we have 20 ounces at a 15% solution of hydrochloric acid. So how much hydrochloric acid do we have? We have 20 times 0.15. That's how much hydrochloric acid we have, right? I got 20 ounces of a mixture. 15% of it is hydrochloric acid, so 20 times 15, right? Now, I need to add to that some water. So watch as I add some water. Right now, I have 20 ounces of fluid, which is, but I'm going to add to that some water W, and now that needs to become 0.1. Okay? So let me describe that one more time. Hold on. So the percentage of hydrochloric acid is equal to the amount of the acid divided by the total solution. So, like, if I've got a little beaker here, okay? All right. I can't draw. So here's my beaker. Oh, for the love of Pete. That's fine. Okay. Y'all are like, just get on with it, man. All right, so here's my little solution in here, and I don't know. Not that you can see it, but there's the hydrochloric acid, right? Well, right now, the entire solution combined is 20, right? When we add some more water to it, okay, we're going to add some more water. We're going to make this new combined amount 20 plus W, okay? But we're keeping this amount of the acid the same. So the amount of the acid stays the same at 20 times 0.15. But the amount of total mixture, the amount of the entire solution increases. All right, let me just do a little bit of simplifying here. 20 times 0.15 is, what, 3? Yeah, I think so. It's bothering me. I'm sorry. I'm sorry. Yeah, okay. Why was I doubting myself? All right. Over 20 plus W is equal to 0.1. All right, I'll multiply both sides by 20 plus W. And I get 3 is equal to, I got to distribute this though, 2 plus 0.1 W. So 1 is equal to 0.1 W. Divide both sides by 0.1. And I get, what is that, 10? So we need to add 10 ounces of water. All right, and we could solve that with a graph as well. We could we could plot this function here and solve for when it equals 0.1, just like we did before. I'll let you try that. But let's double check our work. This is a good one to double check. So I'm going to use the Desmos to double check. So what I'm saying right now is that this, okay, stop. All right. I am saying that this amount of this solution is going to be the 10% that I'm looking for. So currently, we already did it. We know that I have 3, I'll just do it again though. We have 3 ounces of hydrochloric acid pure, right? So if I take 3 and divide that by 30 ounces of water, you can see that's 0.1. That's exactly what I want. Okay, I've got one more type of problem to wow you with. So here we go. Cassie bought 10 desserts at the bakery. Cupcakes cost $2 each. Brownies cost $1.50, not including taxes. Cassie spent $18 total. Okay. I did not ask a question. I know what I meant to say. I meant to say, how many did she buy of each? We'll just add that. How many each? All right, so Cassie bought 10 desserts at the bakery. Got it? Cupcakes are $2 each. I'm going to call X. I'm going to let X be the number of cupcakes, okay? So I know that $2 times the number of cupcakes plus $1.50 times the number of brownies. Now, I don't want to introduce a new variable here, right? But if I bought X cupcakes and I bought a total of 10 desserts, I must have bought 10 minus X brownies. Follow that? Because I'm only buying brownies and cupcakes. So if I buy 3 cupcakes, I had to have bought 7 brownies. Because they always got to add up to 10. So you just have X and 10 minus X. And then that has to equal a total of $18. We're not including taxes. And we'll solve that. Let's see here. what is that, 15. So that makes this 0.5x. And again, we could use the calculator. I told you you could. It's equal to 3, and then I'll divide by both sides by 0.5. What happens when you divide something by 0.5? You double it. So 6. So we have 6 cupcakes and 4 brownies. All right, it is time for you to do the problems. So I suggest that you do whatever works for you. You can work all of the practice problems at once right now, and then go over it with me. Do one at a time, and have me go over them after you do each one. Just how you pause the video. Also, a good idea too is if you're stuck, play the video as long as you need to get a hint, right, on what to do, and then pause it again. Don't give up. Just because you didn't get it the first time doesn't mean you can't take it the rest of the way home. And as soon as you're ready to do that, by all means, please do. Okay, that being said, if you reach this point of the video, I'm thinking you want me to go over this question. So let's do it. Okay, chocolate-covered raisins sell for $1.50 a pound. Yogurt-covered pretzels sell for $2.25 a pound. If a 4-pound mixture of chocolate-covered raisins and yogurt pretzels sell for $8, how many pounds of each type were included? Okay, so I'm gonna let X be chocolate-covered raisins. Okay, so chalky raise. All right, so $1.50 per pound of raisins plus $2.25 per pound of yogurt covered pretzels. Well, remember, we bought a 4-pound mixture, right? So if I got X pounds raisins, the rest of the 4 pounds has to be yogurt covered pretzels. So I just do 4 minus X, and that needs to equal $8. Okay, so we have to distribute. And that should be what, 9? Okay, that was negative 2. So is that negative 0.75? X plus 9 equals 8. So negative 0.75x is equal to negative 1. So if I divide x by 0.75, I should get 4/3. Or 1.33 repeating. So then that makes the answer for minus that, which is, what is that, 2.6 repeating. So we have 1.3 repeating pounds of the chocolate-covered raisins. We have 2.6 repeating pounds of the yogurt-covered pretzels. And that's what we got. And that adds up to 4 and should give us the right price. And again, don't worry about the arithmetic there too much. You would have a calculator. I told you that. I just hate swapping between 2 different menu windows on my computer more than I have to. All right. Rafa invests $10,000 into 2 accounts, earning simple interest for 5 years. One account earns 4% interest per year. The other earns 2% interest per year. After 5 years, Rafa has earned $1,678 total in interest. How much did Rafa invest in an account earning 4% interest? Okay, so $10,000 in the 2 accounts. So that's the total amount right there. We have 5 years. One account earns 4% interest per year. It's simple interest, so it's just principal times rate times time. That's how much interest you get. Notice I'm not saying his total amount of money, because that would be $10,000 plus all that. We're just looking at how much you get in interest. Interest is just what the bank or whoever you loan money to or put money in pays you to keep your money. So we have X amount of dollars at 4% interest for 5 years, plus the rest of the money, which is $10,000 minus the X that I spent in the 4% account, times 0.02. also for 5 years. Altogether, that needs to equal 1678. That's a pretty ugly equation. Let's go ahead and type it in. Let's do that. So I am going to write a function f of x is equal to x times 0.04 times 5 plus 10,000 minus x times 0.02 times 5. What am I trying to get that equal to? I'm trying to get the y coordinate to equal 1678. All right, so now that I got that, let's take a look at it. Just zooming out here till I find the line. There they are. I knew it had to be up there somewhere because that line's way up high, right? Okay, and this better be a number in between 10,000 and 0. 6,780 will give them that amount of money. So that's the answer, 16780. So we did 6780 in the account I called X, which is the 4% account. So that's the answer. And that's the same answer we get if we, went and did the algebra, but you probably need a calculator for each part of those steps as well, because those are pretty yucky numbers. All right, what next? Ben and Kate. Working together, Ben and Kate can paint a house in 10 hours. Ben is somewhat lazy. He knows that Kate works twice as fast as he does. If Ben painted the house by himself, how long would it take? Okay, so distance is equal to rate times time. They can paint one house in 10 hours. So Ben's rate, which I'm going to say Ben, B is equal to Ben's rate, okay? That's how much of a house. That's the amount of house per hour. Make sense? So you take the amount of houses that Ben can paint per hour and you multiply that by 10, and boom, you've got the amount of house that Ben painted over the course of 10 hours. Now, what about Kate's rate? Well, her rate is twice as fast. So twice Ben's also times 10 hours, and combined that gives them one house. If I said they painted two houses, you'd put a 2, etc. So that's 20B plus 10B. That's 30B equals 1. So it turns out Ben's rate is 1 over 30. What does that mean? One house, this is right, houses per hour, in 30 hours. So it turns out Kate could have done this by herself and only worked another 15 hours. But there we go. That's the answer. Oh, did I really put geometry in this? Maybe I just felt like it would make you feel comfortable and special to be remembering the glory that was your geometry course. Angles A and B are supplementary. The measure of angle A is 3x minus 10 degrees. The measure of angle B is 4x plus 15. Angle C is complementary to angle A. What is the measure of angle C? All right, so A and B is what we were given information about, right? So, and they're supplementary. What does that mean? That means that the measure of angle A plus the measure of angle B is equal to 180. Look at that. Look at me using proper geometry notation. All right, so A is 3x minus 10 degrees. Angle B is 4x plus 15. That is a 15, by the way, not a, I don't look weird. Better. All right, so what is that? 7x plus 5. So 7x is equal to 175. Oh, gosh, why? That's not going to be right. Oh, no, it is. What is that? That's 25, right? Yeah, that's 25. 20 times 7 is 140. 140 plus 35 is 170. Okay, cool. All right, so I thought it was going to be ugly, but it wasn't too bad. So what is angle A? Angle A is 3x minus 10. So the measure of angle A is 3 times 25 minus 10. So that's 65 degrees. So then what's the measure of angle B if they're supplementary? Oh, I don't care, actually, because I just want to know angle C. And I know that the measure of angle C is complementary to A. So remember, complementary angles add to 90 degrees. So this is 90 minus 65, which is 25 degrees. All right, not too bad, right? Okay, we have one more word problem to go. Mr. Math has two algebra 2 classes. There are 12 students in his first period class and 14 in his last period class. If his first period class has a test average of 80%, what class average must his last period class have for his overall test average to be 82? Round to the nearest percent. Okay, remember, an arithmetic mean, which is what, when we say average, and we don't give you more detail, being arithmetic mean, add them all up, divide by how many there are, right? What is it telling you? The arithmetic mean is telling you a sum. It's just telling you the sum divided by how many there were. So his first period class had 12 students and they averaged an 80. So the sum of all of his first period students has got to be 80, and we can put decimals, but it should work fine with this. 80% times 12. That's the total amount of points we got. All right. We don't know the sum of his second period, right? We're looking for that. Or what I call the last period. We don't know. We don't know what that is. Okay? But we want the sum of both to be 82 times how many students he has. Well, he has 12 plus 14 is 26, right? So I just got to figure out, what do I need here? So I'm going to say 80 times 12 plus some big X is a whole class that I need, has got to equal 82 times 26. And I'm just going to solve that right quick. I'll let you do more of the algebra if you want by yourself. So I basically just need to do 82 times 26 and subtract 80 times 12. So 1,000, what was it? 1,172. And how many students does he have? 14. So I need the sum to be that. So I need their class average. If I divide that by 14 students, .7 would be 1.4, I think. That's what it said. 83.714%. All right. So, yeah, lots of different ways you could do that. Hopefully that made sense to you. All right, look, the exercise is to write your own word problem and solve it. If you're struggling with word problems and you want to get better, write your own. Try and write one in the style of each one of the problems I gave. You most likely, when you sit down to solve it yourself, you're going to realize you probably didn't give enough information, or maybe you gave more than you needed. But when you start getting a feel for the fact that these are all really the same problem, we're just changing the names of the characters. They are only so many different processes that we can talk about at this point. So when you write your own problems, you're going to really develop an insight and an expectation. You'll see a problem like, oh, I know this problem. He's going to have to give us this. If he doesn't give us that, he's going to give us this. And you can start predicting what's going to happen in these problems even as you read them. So good luck with that. And until next time, and we will be in our new unit after we take an exam on this one. So take care.